Precision in measured numbers. How to show the precision of a measurement in a reported number. Now that we have learned that all measured numbers have uncertainty, how do we show this in using numbers in science? We use a concept called significant figures, or sig figs. The term significant figures, or sig figs, refers to digits that were actually measured or estimated. This is easy when we have done the measurement, but not quite so easy when we are reading a measured number that has been reported. When rounding calculated numbers, we pay attention to sig figs so we do not overstate or understate the precision of our answers. We use sig figs to show the precision of the results of our calculation. When we look at a number, we need to be able to decide how many sig figs are shown by the number. We use 4 rules to determine this. 1. All non-zero digits are sig figs. Clearly, any non-zero digit will have been either read off the instrument or estimated. So the question is really about the zeros, because sometimes zeros are read off the instrument or estimated, and sometimes they just help locate the decimal point. 2. Captive zeros, between 2 non-zero digits, are themselves sig figs. If a zero is between 2 non-zero digits, then it must have been read off the instrument. Therefore, it is a sig fig. Captive zeros are zeros that are between non-zero digits. The most obvious kind of example is a number like 208 grams. The 0 is between the 2 and the 8. Since we can only have one uncertain digit in the number, we must have read the 0 off the instrument, so it is a sig fig. But the 0 does not need to have a non-zero digit on its immediate right and left. A number like 32,007 kilometers has non-zero digits on the left, the 2, and to the right, the 7, of both zeros. Again, the zeros must have been read off the instrument, because only the 7 is uncertain. Leading zeros, to the left of the first non-zero digit, are never sig figs. Leading zeros are zeros to the left of the first non-zero digit. When the first non-zero digit is to the left of the decimal point, as the 3 in the number 35.6 milliliters, we do not even write leading zeros, because they do not mean anything or give us any information. However, when a leading zero is to the right of the decimal point, it helps us locate the decimal point, like in the number 0.00653 kilometers. Leading zeros show us that the length is about 20 feet, not 0.000653 kilometers, which is about 2 feet, or 0.653 kilometers, which is about 2,000 feet. The leading zeros give us important information about the size of the number. It turns out, however, that leading zeros do not influence the precision of the number. Four, trailing zeros to the right of the last non-zero digit are sig figs if written. Let's look at Rule 4 a little more closely. If the trailing zeros are to the right of the decimal point, like, for example, 25.00 meters, Clearly they have been measured or estimated, and therefore all of these trailing zeros are sig figs. The problem is with the zeros to the left of the decimal point when we have very large numbers, like 125 million meters. Are the zeros sig figs or not? The answer is sometimes they are and sometimes they are not. According to Rule 4, if they are written out, they are. But how would we write the number if they weren't all sig figs? The answer is that we would need to write the number in scientific notation. If none of them were sig figs, we would write 1.25 times 10 to the 8th meters. If the number were good to the nearest 1,000 meters, we would write it as 1.25000 times 10 to the 8th meters. The traditional way this rule is written, as it is in your book, is that the trailing zeros to the left of the decimal point are not sig figs unless the decimal point is written. So this number, 125 million meters, has no trailing zeros that are sig figs, while this one, 125 million decimal point meters, shows all the trailing zeros are sig figs. Personally, I think my Rule 4 is easier to apply when you are learning about sig figs. So, once again, here are the 4 rules for figuring out the number of sig figs. Pause the video to write them down if you wish.